Hello, everybody. This is the Non-Renewable Energy lecture. And so let's start by defining non-renewable energy. This is energy that cannot be replenished, at least on a human time scale, right? So fossil fuels are stored solar energy. It's basically a bunch of plants that were compressed and heated, or algae that was compressed and heated over millions of years to create the coal, oil, and natural gas that we have today. So when we think about non-renewable energy, it's the fossil fuels and then nuclear fuel, which is the fission of uranium, right? So why are we studying non-renewable energy? And this is an ecology, a biology course. So realistically, energy isn't necessarily a biological topic, but the effects of using that energy are definitely a biological topic. So there's many hidden costs that we don't see, or that a lot of people are not really aware of, that are impacting ecosystem health and potentially personal health. So let's start by thinking about coal. Okay, this is the oldest fossil fuel that humans have been using. Coal really started in the early or late 1700s when we had steam engines, and it was a better fuel than wood because there's more energy packed into an equal amount of weight or volume of coal compared to burning wood. Now, what coal essentially is it's compressed and heated swamp plants. Now, if you look at where coal is coming from, it's really coming from this Carboniferous period, right? So 300 to 350 million years ago, essentially. And what's interesting about this time frame is, so one thing you might ask is, well, why do we not see coal being made now from swamps that we have today? And the answer probably lies in the fact that at this time we didn't have wood-eating fungus. So right now we have a bunch of fungus that when a tree dies and falls over, fungus attacks it and decomposes it. But the swamps of the time of this 350 to 300 million years ago was probably basically a bunch of dead trees lying around, and they weren't decomposing because we didn't have the funguses there. Interestingly, this is right here is a picture of a dragonfly that we found fossils for that were actually that large. May not have looked exactly like that, right, with that coloring, but we know that is how big some of these insects were at this time. Now, there's 4 different types of coal, all of different quality, that are then used for different purposes. I'm not really going to get into that, but some of the lower grade coals that we use are really supplying that energy. So in the US, our electrical energy is about 40% coal. China and India are somewhere about greater than 60% coal, and China and India are really making a lot of coal-fired power plants currently, right now. Now, what's the environmental impact of coal? Now, it's very similar to a lot of fossil fuels in that there is carbon dioxide released, right? So I'm not going to really talk that much about carbon dioxide. We'll wait for that for the air lecture when we're talking about air quality and air pollution. But one thing that's really kind of unique to coal is that the mining of it takes a lot of landscape disturbance, or it creates a lot of problems with just completely destroying certain landscapes. It kind of depends on how the coal is mined. If the coal is relatively shallow from the top of the earth, then they'll just basically do this surface mining like they have here, which they'll just get rid of what we call the overburden and then scrape into the coal below. And but once the coal is actually a lot deeper, then we kind of have those mines, that the deep underground mines that you think of when you're thinking about mining. But the surface mining, strip mining that we see is extremely bad for the landscape, because you're digging up a whole lot of ground and moving it over, and the stuff that is along with coal deep underground is actually really bad and can cause a lot of water contamination and soil contamination. And what we get is, from these surface mines, you get a lot of production of acids. So the soil is really, that overburden that they're moving is really acidic, has lots of sulfuric acid, lots of iron, and when these water sources break through either dams or their containment, what they see is they really have really bad problems. This is an example of acid mine drainage break from a coal mine. So and it pretty much just eliminates everything alive in the water. So coal is, for a really great energy source that's very plentiful. It's by far the most common fossil fuel that we have on the planet, and there's plenty of coal like the amount of coal, we have plenty of coal for a long time, much more than we have of oil, but there's some pretty bad consequences for using that. Let's switch over to oil then. I think most people are relatively familiar with oil, and we use this in our cars. Plenty of people are familiar at least with some way of using oil. The reason why we use oil is that there's more energy per weight even than coal, right? So there's a whole lot of energy in oil. And it's also easier to extract, right? It's a liquid. We can drill down and pump it out rather than having to dig down and actually, dig it out with machines or shovels or that kind of thing. It's not as bad for the carbon dioxide emissions, but it still releases a lot of carbon dioxide. Now, the cleanest burning fossil fuel is natural gas. I put this in quotes, that it has no pollution, that it's least disruptive to the environment, and if natural gas is actually burned correctly, it really doesn't release really any carbon dioxide. But rarely do engines actually burn it absolutely cleanly, and it's even worse in the production of it. So natural gas is 70 times more powerful of a greenhouse gas than carbon dioxide. So a small leak in the production of it makes a big impact when we're thinking about global warming and climate change. So what we see is, if you leak during the production, or the production and use of it, if you leak 3% of coal, of the natural gas, it's equal to the carbon dioxide emissions that are coal. And production is oftentimes leaking much, much more than the 3%. So in some ways, there's a lot of hope put into natural gas, but it's in some ways a false hope. Nuclear energy has, generally a relatively bad reputation, and probably due to its connection with nuclear weapons, right? It's a very different process, though. Like, nuclear power generation cannot create the huge explosions that we see, in every science fiction movie. We have 4 nuclear power plants here in Wisconsin, 2 up by Green Bay, 1 by Kenosha, and 1, I'm not sure what city is over right here right now, but there's there's no person could go into that nuclear power reactor and change some switches and make it blow up like a nuclear bomb. That's not how it happens. Yes, there are accidents that have happened, and that's usually to some side effect of the process, creating hydrogen gas that then explodes, or a bunch of steam being released that can create some radioactivity problems. If a nuclear power plant runs fine, and the overwhelming majority of power plants have run just fine. There's really only been 3 or 4 major accidents that we've had. I'm thinking of like Chernobyl, the 3 Mile Island, and the Fukushima Daiichi in Japan, and those have been really the only high-profile accidents that we've actually had with nuclear power plants. But there can be some pretty bad problems with it. What we see is there's really no ecological impact from the radiation, right? When a power plant is actually running, you get less radiation. You could live right next to it, and you would get less radiation from the power plant than you would just get from like walking around in just on a day-to-day, basis. Really, where the ecological damage comes from is where we're mining from it. So, this is the Colorado River. It's one of the main rivers in the southwestern United States, and there is a uranium mine right here, right next to it. And if this river floods, it could potentially get into the uranium mine. And this is, a deep surface strip mining operation where there's a lot of nasty chemicals in this dirt that could potentially get into the water. So realistically, the radiation really isn't the problem. It's the mining that causes more of the problems. All right, that's it for this lecture, and see you all later.